Everybody loves machine learning, right? It's hashtag AI, hashtag machine learning, hashtag data science, hashtag, hashtag, hashtag. So we're going to make a couple assumptions about you today. One, that you're interested in machine learning. A lot of you are here. And two, that you know basically nothing about the subject. So if you're an expert in machine learning already, you are about to be entertained, but also maybe a little underwhelmed by what you're going to hear. Because we're really trying to target those folks that are interested in machine learning and don't really know where to start, because it can be pretty daunting. If you saw the last talk, that gentleman was, whoa, really super smart. I was like, okay. So it can be kind of intimidating, so we're going to show you a nice, simple way to get started. But before that, let's justify why you should be listening to us in the first place. So my name's Dave Langer. I work at a local startup called Schedulicity, where I run the analytics team. I've been working at Schedulicity for about a year and a half. I moved to Bozeman about a year ago. Before that, I worked remotely from the Seattle area. Before Schedulicity, I worked at a company called Data Science Dojo, where we performed week-long intensive boot camps. So I've trained hundreds of working professionals on the basics of machine learning and data science and predictive analytics. And one of my favorite things in the entire world, the mighty R programming language. Yeah, baby. Okay. But probably more importantly than that, I also worked at Microsoft for 8 years. Don't hold that against me. On the SQL Server team, amongst other places. But probably more importantly, for maybe some of you in the audience today, I'm an avid YouTuber, where I put up data science tutorials. If you go to YouTube and you search David Langer, data science, you'll find a whole list of videos that I've made over the years on various data science topics if you're interested in learning more. I'm also a spammer on LinkedIn, big time. If you remember the keynote, the lady was talking about PR and self-promotion. Oh, I am shameless. Shameless in this regard. But what I do is I post content mostly aimed at people interested in getting in analytics and machine learning and data science, trying to separate the hype from the reality. Step away from the deep neural network, people. Step away from it. You're not going to need it most of the time. And then lastly, and probably most importantly, I am human to my beloved Doberman Zoe the Dobie. So if you want to join up on LinkedIn, give me a request and I'll gladly accept it and you can start taking a look at my content.
Okay. And I'm Caitlin Johnson. I am a data scientist on Dave's team at Schedulicity. I got my degree here at MSU in applied mathematics, and then following graduation I rounded out my skill set a bit and worked a lot with humans. I got a job in the customer support department at Schedulicity and gained a bunch of business knowledge and understanding of our user base there, and that really helped my transition into my current role, which was a little over a year ago. So I'm still rather new in my machine learning journey, so when Dave brought up the idea for our talk today, I was super excited to offer a suggestion of what a first step might look like, because I know it can be really overwhelming. So, let's get into it. Okay, first thing, let's imagine you are stuck on a deserted island. You can only take one thing with you. Sunscreen is a top contender for me. But in all seriousness, it's probably wise to equip yourself with a tool that is going to serve you in a wide variety of situations that are going to come up that you don't quite know what they're going to be, right? Think Swiss Army knife. So what Dave and I want to talk to you about today is the Swiss Army knife of the machine learning world, which is the mighty random forest algorithm. This we love and thought it would be beneficial to share with you guys for a couple of reasons. One, it's super approachable. Right? You don't need extensive technical skills or deep mathematical understanding in order to use the tool. Two, it's applicable. It's a super versatile algorithm that is a great solution for a number of business problems that will come up. And three, it's explainable. Machine learning models often work magic behind the scenes, and you have no insight into how they worked, why they worked. But the random forest algorithm actually explains itself. Once it has been trained, you can understand kind of how it worked, what went on behind the scenes. So we want to offer you a high-level introduction to the algorithm today, just some understanding of kind of how it works. We'll do a little QA, and then we're also going to offer some additional resources for anybody that is interested and wants to dive deeper into more of the technical stuff and implementing it. So thanks for joining us. And I almost forgot. You don't need to take our word for it. Xbox Connect, Microsoft understands the power of the random forest and used a variation of it in order to power their Xbox Connect tool, right? Where you don't have a controller, but you're like dodging logs in your living room. So that's just a real world example of the power of the random forest.
Okay, so as I mentioned before, hundreds of working professionals around the United States and Canada have had the distinct misfortune of learning machine learning and data science from me. What I found in that particular time frame of teaching people is that you don't always want to start with the technical details, right? I mean, this is a technical conference. I'm assuming all of you guys got some coding chops. But it doesn't always make sense to start with code or with mathematics. Usually what it makes more sense to start with is some sort of metaphor, some sort of mental framework to think about the problem intuitively and then dive into the technical details later. And that's what we're going to do today. We're going to use this as our metaphor, as our frame of reference, a classroom. And what we have here is we have this teacher, God love her. She's doing God's work. She's got the patience of Job. She's trying to teach little Jimmy here something about animals. And Jimmy is just not cooperating. It's not an elephant, Jimmy. Good guess, though. It's an armadillo. And look how sad he is about the fact that he got it wrong. Little Jimmy needs a lot of help. So this is going to be our frame of reference, right? And later on, we're going to take this metaphor so far, Caitlin's going to transform these little kids into trained machine learning models. It's going to be awesome. Just wait for it. Okay, so today we're going to talk about a branch of machine learning called supervised learning. Machine learning is a broad academic pursuit, and there are many, many aspects to it. There's unsupervised learning, the talk some of us just saw last, reinforcement learning, supervised learning, dimensionality reduction. There's a whole bunch of things that go into machine learning. Today we're going to focus on supervised learning because that's typically what you end up using most of the time in most situations in the business world, because you want to be able to predict something. So that's a supervised learning task. And again, we've got our metaphor here, okay? So I want you to think of you as that teacher doing God's work with the patience of Job. And by the way, if you get into machine learning and you want to deploy production systems, patience is going to be your friend because it is ridiculously hard to do well in the real world. So this is you. You're the data scientist. You're trying to teach little Jimmy. Little Jimmy's the machine. Now here's the thing. As we saw earlier, we love little Jimmy and he's cute, but he doesn't seem to be the brightest bulb in the pack, if you know what I'm saying. He's mistaking an elephant for an armadillo. This is great to think that. The machine is stupid. Machine learning algorithms are stupid. If you don't take care with them, you'll get weird results, and we'll see an example of this later on. So you are critically important so far in the process. Once machine learning algorithms get smart enough where they don't really need humans anymore, it's a good thing we live in Montana. It's Skynet time. It's time to head to the hills with your God, your guns, and your goals. Okay. So right now they're done. So keep that in mind. This is at base what supervised learning is. It's a combination of three things, right? If you're in the data science world, you know we love Venn diagrams. We see them all the time. You have data. That's the single most important thing. No data, no dice, nothing to do. It's the raw material, right? If you've seen that Economist article, it's the new oil, right? So you have to have data, step one. Once you have the data, cool. That's the most important thing. Then you can pick your algorithm. Today we're going to be talking about the mighty random forest. That's the algorithm. And then lastly, you have to have some sort of training regimen, right? You take your algorithm, you take your data, and then you have to train it. Most prototypically, this takes the form of, and I'm going to drop a few terms on you. If you want to add them to your slide decks to shock and awe executives, feel free. Hyperparameters. Remember that one. Hyperparameters is nothing more than the knobs and dials that you tune on a machine learning algorithm to produce a result. So that's part of your training. We'll talk a little bit more about knobs and dials later. Now, the intersection of these three things give you what you call a model. The random forest by itself is just an algorithm. Data just by itself is just data. Training regimen is just some sort of abstract concept of some guy standing up there doing this. The model is the intersection of these things. That's actually the piece of binary, right? It's a pickle file if you're in Python. It's an R data file if you're working in the best programming language you ever are. Right? That's the thing you can pick up and move and deploy. It's the intersection of these three things. Okay. Now, as I mentioned earlier, data is the single most important thing. It is the most important thing in supervised learning. There's an adage in machine learning that goes, data trumps algorithm. That's absolutely true. So data is the most important thing. So here we have a distorted chunk of data here. Now, in supervised learning, your data is going to come in tabular format, either in a PowerPoint table, or an Excel spreadsheet, or a CSV file, or a database table, whatever, right? This is your data. Now, if you want to be really cool, once again, and sound like either Morpheus or somebody that's in the machine learning world, you would call this a matrix, two-dimensional representation of data. And this is going to be super important. Each row represents a thing, where once again, if you want to be cool, an observation. I have a dog, a snake, a lizard, a cat, right? Each one of these rows represents an animal in this particular data set. And each one of these columns typically represents a feature, some sort of attribute, some sort of characteristic of the thing. For example, dog is man's best friend, generally speaking. Now, your mileage may vary, as you'll see later. Maybe you like snakes and lizards, that's totally cool, down with it. But traditionally, dog is considered man's best friend. So this is going to be super important. It all starts with the data. Now, as Caitlin said, one of the most interesting things about the random forest algorithm is that it's approachable. You can get really, really far in practically applying the mighty random forest to your business problems without really needing to know a huge amount of the technology, the mathematics, the theory underneath it, because it's really intuitive. This is one example. What is a forest? It's a collection of trees, right? The mighty random forest is a collection of trees. Whew, approachable number one, right? Idea number one. And this is great because we are all familiar with decision trees, right? We actually run our life most of the time through implicit decision trees, whether we draw them out in PowerPoint or Visio or whatever or not. Right? So we're going to learn about decision trees because they are the constituent element of the mighty random forest. Okay, so decision trees. So decision trees is a fundamental machine learning algorithm. If you go to any sort of ML class in a computer science program, it is extremely unlikely that you will not cover decision trees because they are that fundamental. That fundamental. They are super easy to understand. They're very intuitive. And also, once again, here's another buzz term for you. Shock and awe on your PowerPoint slides. It's a nonparametric method. That sounds pretty cool, right? Oh yeah, I use this decision tree. You know, it's a nonparametric method and work really well on our data. Awesome. Executives love that kind of talk. Trust me on that. So, what's really great about decision trees is that even though the mathematics, which you can learn, and it's not that complicated, or the coding, which is not that complicated, you can just think about the decision trees at a higher level. How do they work? And they work pretty simply. They just literally just say, look, I got your pile of data, Dave. And I'm going to go through it one at a time, step by step, in an iterative process. I'm going to take all of the things, the snakes, the dogs, the lizards, and I'm going to just try and put them into piles. And my goal is eventually when I'm done, is I will have a pile of only dogs, and a pile of only cats, and snakes, and lizards. And that's how they work, iteratively. They just go through your data and they find out how can they better and more often just split your data into nice little piles that are uniform. So, we have our data. And for the sake of argument, this is all the data we have. 4 data points. Now in the real world, you're going to have lots of data. Ideally, as much data as you can get your hands on. But this will work for today. So the first thing the decision tree does is says, okay, Dave wants me to learn something. Right? This is little Jimmy. Little Jimmy's not too bright. So the decision tree says, I want to learn something. And the first question it asks is, it says, look, which of these features splits these labels the best? Because I'm trying to get nice, clean paths. This is how the decision tree works. So the first thing it does is says, hey, you know what? This warm-blooded column works pretty well. Because you'll see here, it separates dog and cat, highlighted in blue here, from snake and lizard in purple. That's a pretty good, clean split, right? I got all the warm-blooded animals in the world down one side of the tree, all the cold-blooded animals down the other side of the tree. That's a pretty good split. Now here's the thing, and this is really super important to understand. Notice that the popularity on YouTube, now as an aside, I did try and find snake and lizard videos. There's way more cat videos than snake and lizard videos on YouTube, so that's where that comes from, by the way. But if you look at it, you'll notice that the data, the information in each of those columns, each of those features, is exactly the same. Right? The Y's are in the same place and the N's are in the same place. So the question is, how does the decision tree pick which of these to use if they're exactly the same? And the answer is, trees are greedy. I want that marshmallow now. Okay. How many folks are familiar with this really super sick and twisted psychology experiment that was done on little kids? Where they bring them in. They got this line of kids and they're all sweet and innocent and they bring them into this lab and they sit them down like, Jimmy, would you like one marshmallow now? Or would you like 2 marshmallows in 10 minutes? How twisted is that? Because me personally, I love marshmallows. They're soft, they're chewy, they're sweet, they're delicious. I want it right now. But what they found is that over time they did a longitudinal study. Did I pass that right? You guys know what I mean. Right? They followed these kids over time, and what they found was those that waited, those that were able to delay gratification, did much better in life. They did much better in life. Caitlin was just saying the other day, like they probably had really awesome 401ks by the time they retired. Right? They're delaying gratification. Trees are not like that. Trees are like little Jimmy. Jimmy's like, marshmallow now. Right? Trees are greedy. They're not very smart. So what it does, the tree just picks the first one that it finds and says, I don't care. Maybe there's some advantage to having popularity on YouTube later, but I don't care. I'm taking that marshmallow and eating it right now. So that gets you the first step. Right? Trees are greedy. They're not very bright. They want marshmallow now. So it picks that first feature that it finds and says, look, I'm going to go ahead and split my data first and foremost by whether or not the animal is warm blooded. And then you say, okay, what's next? Right? The tree says, okay, I'm not done because I want to try and get clean piles of dogs and cats and lizards and snakes. So then it says, look, I got to look at the features that remain because I've already used this feature, this column. Right? And popularity on YouTube doesn't make any sense because it doesn't give me any additional information, so I'll just ignore it. So it just looks at the last 2 that are left. And it says, okay, which of these works for me? Well, legs don't work because cats, generally speaking, and dogs, generally speaking, have 4 legs. Unlike some of those YouTube videos where you see a little 2-legged dog that hops around and is just happy, right? But generally speaking, dogs have 4 legs. So it picks man's best friend because that feature allows to differentiate dogs from cats. Right? Number of legs won't work. It doesn't provide any information. But man's best friend does. So it picks that one. It says, you know what, this is sweet. The right side of the tree, or left side, depending on how you look at it, left side of the tree is done. My dogs and cats are cleanly separated. They're cleanly separated. So it moves on and says, okay, what's next? And it says, which of these features can cleanly separate the snakes and the lizards, right? Because my dogs and cats go down this side, my snakes and lizards go down this side. And man's best friend doesn't help. Again, I may have mentioned this, right? If you like snakes and lizards, I apologize. But generally speaking, a dog is considered man's best friend. Both are in, so that doesn't help. But number of legs does. I want to see if my laser pointer works. Oh yeah, love it. So that snakes have no legs, so I can use that feature. Now I'm done. I've cleanly separated my dogs from my cats, from my lizards, from my snakes using this data set. Now this is a contrived example to be sure, but this is the intuition that you need to have. Decision trees are awesome. I mean, the way they function makes total sense, right? You don't even have to know the mathematics or the coding. It just kind of makes sense the way they work. But we got a problem. If you're familiar with Lord of the Rings, right? This is Treebeard. He got all ragey on this guy's benzo. Trees can go wild. They can get crazy. They can get angry. They can do bad things. So as awesome as decision trees are, and there are many reasons why they are, and we'll talk about that later, they have one major problem, one major sin, and that is they overfit. That's another cool machine learning term. And what that means is basically you can give a set of training data to a decision tree, and it will try to its best ability to memorize that data set. Memorize it, because it wants to create the cleanest piles of data at the end that it can. And that means that sometimes it will do dumb things. Remember little Jimmy? Sweet, innocent little Jimmy? He tries so hard, but he's not the brightest bulb in the pack. Decision trees like that because of the greed and because of what they do. So let's see an example of how this can manifest. Now notice, I've taken our matrix, and all I've done is I've added a column. Name. These animals are pets, let's say, and they have names. Now here's the problem. Because of the greed and the relative stupidity of the decision tree algorithm, it's going to say, you know what? That's a really good feature. Does that feature cleanly split all of my data into nice little files? Hell yeah, it does. Oh, there's your tree. This is little Jimmy, baby. It's an armadillo, Teach. This is little Jimmy right here, right? He doesn't know any better. He's like, oh, that name feature is really good. Now, how many people here think this would be something you want to deploy in production? Good. Every now and then you get somebody who's like likes to be radical and be like, yeah, I'd do it, Dave, totally. No, this is bad, because think about it this way. If you deployed this into production and a dog named Fido came in, what kind of animal would you say it is?
It's not an animal.
Who said snake? How many people said snake? Right! Okay, is Fido's name Dawn? No. Is Fido's name Chris? No. Is Fido's name Larry? No. Oh, he's got the snake. Right? The machine is dumb. Never worry about hashtag AutoML or anything like that, at least for right now. There's always room for the data scientist. You need to understand this stuff, right? You have to understand the data. And once again, until machine learning algorithms get to the point where they can select their own data automatically, then it's Skynet time, right? But before then, you as the data scientists are supervising the learning process. You do things like this. You say, look, you know what? If there's a name there, ignore it. Okay. Last thing that you need to remember, and this is a prime example, and Caitlin will go into more of why this is super important. Trees can radically change their shape simply by changing the data that you give them. This is an example, right? This looks nothing like the other tree. And all we did was add a single column.
Okay, so as much as we're falling in love with decision trees, it's sounding like in practice they suck, right? They're too good. They memorize the data and then they overfit and they are totally worthless in production. So the random forest has the power to harness the goodness of the trees and leave the bad behind. And the way that it does this is by building a forest, right? Bringing multiple trees together. So let's talk about how that is a powerful step. So it's basically this idea of harnessing the wisdom of the crowd, right? Where the idea that you compile a room full of people together and you're all tasked with making a decision. And as a group, you will make a better decision than any individual in the group. But of course, there's the whole like angry mob thing that can happen. So there are some conditions for a group to be intelligent. One is for the individuals in the group to be diverse, right? You don't want them all to be the same. Like thinking about 1,000 Dave Langers on stage, and you ask them what their favorite movie is. And you'd probably get back 1,000 times.
The Fifth Element.
Fifth Element. I was going to say Empire Strikes Back. Okay.
Oh, that's a good one too.
Okay. So it's, a lot of hand flapping going on, and it's not very helpful, right? So you want diversity. You want different perspectives coming together. Second, you want independence. You don't want them getting each other riled up, right? Well, he said yeah, so I'm going to say yeah. And third is decentralization. You don't want to be dealing with a lot of bias. So this translates in the machine learning world to what's known as ensembling. The idea of compiling multiple models together and taking their predictions and taking the average or the majority vote from all of their predictions, and you end up with a more accurate prediction than you would have from any individual model. But of course, the fine print being ensembling works best when those models are diverse and have a low correlation across their predictions, right? So that you're getting different perspectives. And the random forest manufactures diversity for us across the trees within its forest. So it becomes a super effective ensembling method. So let's jump into visualizing all of this. Okay, so let's start with this idea of an ensemble, or a forest, in other words. And so we're back in the classroom. We have our 3 kiddos, and they're each representing a decision tree. Now, I call this a petite ensemble because in practice, random forests are made up of hundreds of trees typically. But for the concept and just for the sake of a slide, we just are dealing with 3 today. So, wait, how do I point this thing? Right there. I don't need to point, it's okay. Okay, so each one is a tree, and below them are the data that they're being trained with. Okay, so you'll notice they're all being trained with the same exact data. 2 dogs, a cat, a snake, and a lizard, and they're being trained to try and recognize and label animals, right? So here they are. They're all looking very similar to one another, and they're saying, okay, we're trained up, we've built our structures, we're ready to go teach. Give us some real data, some new data. We want to make some predictions. So the teacher says, all right, okay. I'm excited to hear that, kids. So she sits down, she opens the book, and she shows them this little guy. And she says, okay, kids, what are we looking at today? What is this animal? And so Jimmy, Susie, and Bobby, they look at this little cutie and they think he's got fur, and he's got 4 legs, and he has pointy ears, and he's not bigger than a bread box. So that is a cat. Okay, so all 3 of them have overfit to the data that they were trained with. Okay, so the dogs that they learned don't look anything like that little guy. He looks more like a cat because he's got pointy ears and he's not bigger than a bread box, right? So this is an example of a worthless, non-diverse decision tree ensemble. Okay, so now let's talk about how the random forest manufactures that diversity so that we can harness the wisdom of the crowd. So it does a couple things. The first is what's known as bagging, and that is selecting random samples of the original data set and then giving that to each one of the trees within the forest. So none of them get all the data to be trained with. So it's just a random shake of the dice, and little Jimmy gets 2 dogs and a lizard. Random shake of the dice, Susie gets 2 dogs and a snake. Random shake of the dice, and Bobby gets a dog, a cat, and a lizard. So already from what Dave taught us, we know these decision trees are being trained with different types of data, so they're already going to start looking very different. And ensembling, if a little diversity is good, a lot of diversity is even better. So the random forest, it doesn't stop there, okay? It's got a second step to randomizing the data, which is known as random feature selection. Okay, so bagging is this idea of randomizing the rows that each tree is trained with, right? The whole row for a cat was just removed for Jimmy and Susie. Random feature selection is this idea of randomizing vertically within the matrix. So for instance, the matrix that Dave showed earlier, the number of legs column has been completely removed for Jimmy, right? He has no insight into that feature, so he can't use that to split the data and ultimately make predictions. Susie, her poor critters have all been decapitated, so she's a little bummed out, but she's still able to split the data and make predictions on the rest of the body. Bobby, meanwhile, random shake of the dice, his matrix no longer includes any information on the tails, if they have a tail, if they don't, if it's bushy. So these trees are starting to look wildly different, right? So now they're trained up, they're all independent, they're all diverse, and they say, okay, teach, we're ready to get some more new data. Like, show us, we want to make some predictions here. So the teacher says, I'm glad to hear that. All right, kids. Okay, so here we go. She opens the book. Let's say it's the first time they're seeing this little guy. She says, okay, what are we looking at? What kind of animal do we have today? And now each of the kids looks at this and registers different things about it, right? They don't all look at it in the same way because they have access to different features, right? So some of them are looking at the number of legs, some of them are looking at the pointy ears, some of them are looking at the fact that it has fur. So let's see how they do. Okay, pretty well, right? Okay, so Bobby's still stuck on the kitty, But that's okay. That's okay, because you're going to still have bad trees in your forest. But that's the whole idea, is that you're having this diversity, right? So he doesn't get a gold star today, but as a group, they have given us an accurate prediction because we're taking the majority vote, which is a dog. So not only are we getting an accurate prediction, but that explainability that I talked about earlier, that is what's known as feature importance. And that the random forest, once it has trained its trees, before it even starts making predictions, the algorithm pretty much looks down on all the trees within the forest and recognizes which features were used the most across all trees to split the data. And then it ranks those for you, so you have insight into which features are the most powerful in recognizing and making those predictions. Okay?
So as you've heard Caitlin and I say over and over again, the mighty random forest. So hopefully we've given you the hard sell, but we're not done yet. We're going to give you a little bit more about why, if you're getting started in machine learning, this is a great algorithm for you to use as your first test project or your first production system, what might have you. The random forest is mighty. Okay, it really is. So first up, and this is really super awesome, is that the random forest works with your data out of the box. There are some other machine learning algorithms like linear regression, for example, where you have to pre-process your data to get it to work with the algorithm, because the algorithm makes certain assumptions about your data. Random forest does not, because decision trees themselves make no assumptions about your data, and since a random forest is built off of decision trees, you get that goodness flowing through it. So minimal data pre-processing, which is awesome, because if you haven't heard this dirty little secret, 80% of your time when you do data science and machine learning is not the fun stuff. Well, it depends how you define fun. Most people define fun as the machine learning part. 80% of your time is getting data, understanding data, cleaning data, bitching about the fact that the data is so dirty, and then moving on from that, and then getting more data, and then bitching about how dirty that data is, and then moving on from that, right? So, like I said, patience is so key in this field. So it's nice when you don't have to worry so much about your data. Right? You say the algorithm just works with it out of the box. Plug and play training. Remember what I said earlier about the knobs and dials? Right? For example, artificial neural networks have a huge number of knobs and dials. To find the optimal neural network, deep neural network, it takes a lot of time and effort. Random forest, by way of comparison, the defaults work well out of the box across a wide variety of scenarios, which says I don't have to worry about that. I can just grab some data, throw it in the random forest, and see what happens. Sure, you can tune it later if you want to, but you don't have to. You get really good results without even doing that. And that allows you to spend more time worrying about what really matters, which is the data that you feed in. Rather than tuning, you feed the data in. That's really super important and makes you a lot more efficient. Broad reach, right? We saw it earlier. Yes, it was my idea to put the Connect up there, obviously, as a former Microsoft employee. But the mighty random forest has been used in a very, very wide number of business scenarios in production, ranging from the Connect, which is visual motion detection, all the way to Quora. If you're familiar with that website, their original question classification system was built on a random forest. And if you follow Kaggle and know what that is, there was even a competition. They wanted someone to improve on their existing system, which was built on random forest. This one is awesome. I cannot stress this one enough. The early warning system. The mighty random forest, when you train it, can provide you a reasonably accurate estimate of its error rate, or reflexively, its accuracy rate. Said, hey Dave, you know what? You're training me on this data. I can present you with an estimate. If you did put me into production, approximately how well would I do? Now this is great, because the last thing you want to do is put that name-based tree in production and then have to explain that to your boss, like, well, you know, 80% of our customers are snakes. Oh man, we totally missed the marketing on that. That would be bad. No bonus for you, right? So this is great. The early warning system will tell you up front how well can you do with the data, and that makes your problems a lot more tractable. Because if you get a really, really bad error rate, and this is all the data you have, you can quickly find out this isn't going to work. And that's something that's important, because just because you want to build an effective model and put it in production does not mean that you're going to be able to do that. A lot of times you can't, because you don't have sufficient data, you don't have the right data, you don't have enough data. So knowing that sooner rather than later is good. And then, of course, everything else that we've been talking about, right? It works with the awesome decision trees. It takes all the goodness of the awesome decision trees, gets rid of all the bad, gives you feature importance, all kinds of good stuff. So this is why, if you're going to pick one machine learning algorithm to use for your first project, you can't really go wrong with a random forest. You really can't go wrong. So, hopefully I've given you the hard sell and I've got you guys excited about it. If you're going to start a machine learning project, if you want to learn more about the random forest to use it in. So we got Victor's decision tree learning playlist. This is really, really great. It's a series of short videos. It's free. It's on, well, you have to watch an ad. But it's on YouTube. And he covers like the mathematics, for example. The mathematics are not that difficult. So this is a great, great resource. Simply Learn's tutorials on decision trees in R and the random forest in R are also very good. I've watched them. Yes, they have Python too, if you're interested in that sort of thing. And then lastly, some shameless self-promotion. Remember the PR stuff from the keynote? Right here. I also have some tutorials, as I mentioned as well. This one takes the complete life cycle from data analysis all the way through model training and submission using Kaggle's Titanic competition as a vehicle. But if you're more traditional and you don't like YouTube, you're more into books, ISL is a great book, and the good news is it's free. You can get the PDF from here for free. This is a great introductory book. These books are also good. I am a big fan of this one right here. It's a great book. It's a great textbook. It's a good blend of the intuitive and the descriptive with some mathematical rigor, right? It's not too mathematical, and it's not mathematical as well. So that's a good fit for folks, if you need any more. And what I'll do is I'll say thank you and open up the floor to questions, and then I'll go back to the